Imagine PostgreSQL is a restaurant. Rows are tables, the dinner kind. Queries are diners, and logs are the reservation system. Today, we are going to understand every type of Postgres log using this analogy. And more importantly, learn how to diagnose when your diners are blocking each other and nobody is eating. Locking is how Postgres prevents conflicts between concurrent operations. Most of the time, it works invisibly. MVCC handles read-write concurrency without explicit locks. But writes can conflict with writes, and certain operations like schema changes require exclusive access. Understanding log types and how to diagnose log contention is essential for running Postgres under real production load. A deployment pipeline ran a command alter table users add column last logging timestamp during peak hours. This alter needed an access exclusive log, but a long running analytics query had been holding a read log on the same table for 20 minutes. The alter queued behind it, waiting, and every subsequent query on the user's table queued behind the alter. Within 3 minutes, the connection pool was exhausted. The app went down, not because the alter was slow. It would have taken milliseconds, but because it was waiting for the read log and everything else was waiting for it. A cascading log queue. Create a sample users table and insert some data. Before creating a log scenario, let's see how we can inspect logs in PostgreSQL. Here I am joining pg_logs, pg_stat_activity and pg class to see what logs exist on the users table. Open window 1, start a transaction and read from the table. This query holds a shared log on the table. Open window 2, try to modify the table structure. This operation requires an exclusive log, so it will wait for the transaction in window 1 to finish. Open window 3, now let's run another query. This query is now blocked because the alter table is waiting for an exclusive log. Now let's detect which query is blocking the others. We can see it here. Now, commit the transaction. As soon as the transaction commits, the log is released and the waiting queries continue. Acquire advisory log. This acquires a manual log using the key 12345. Try log from another session. Now, other session tries to acquire the same log. Release advisory log. This releases the advisory log so other sessions can acquire it. PostgreSQL also provides a simple function to find blockers. This quickly shows which sessions are blocking others. Create another blocking scenario. This transaction again holds a shared log. Now configure a log timeout. This means Postgres will wait only 5 seconds to acquire a log. Set log_timeout to 5 seconds in your migration scripts. If a migration can't acquire its log within 5 seconds, it's better to fail and retry than to queue up every query in your application.